in that environment. In any major ecosystem, there's two major systems that are at work here, and two major systems that you have to study. One is going to be the system of energy flow, and a system of chemical cycling. And you just have to remember that energy flows into a system. Energy flows through a system or through an ecosystem. Whereas chemicals or substances are cycled. If you want to think about it, it's also recycled as well. Ecosystems are classified as being open systems. And what does that mean if an ecosystem is classified as an open system? That's true. Maybe a little bit more specific though. There's like energy is not sealed in a bubble. An ecosystem's not in a bubble. So with the concept of open systems, that means that if you have your system, and then on the outside of that is your surroundings, everything that surrounds the system, energy flows into and possibly out of any given system. Now it makes sense the more energy goes in, and that's why I've drawn a longer line for energy going in than one going out. But energy does go in and exit in an open system. Are you an open or a closed system? Do what? Are you open or closed? You're open because you have stuff coming in, stuff going out. Cool. Let's talk about trophic levels real quick. This should be 100% review. Let's talk about, or we'll write down primary producers. And then we'll talk about primary consumers. Then on the next level is going to be a secondary consumer. Then possibly a tertiary consumer. Right? Remember, your primary producers are going to be like all of your autotrophs. Specifically probably a photoautotroph. Not necessarily always, but typically probably a photoautotroph. Primary consumer, that's another name for it. Herbivore, right? A secondary consumer could possibly an omnivore or a carnivore. So your primary producers dump off energy to primary consumers. Secondary consumers get energy from primary or possibly from primary producers. Tertiary consumers can consume at all levels, so draw an arrow there, an arrow there, an arrow there. Whoever gets the arrow is getting the energy, so it would make sense that your tertiary consumers can get energy from any which level. Cool. And then off to the side, you have a couple of other creatures that are at work here. There's the detritivores. What does a detritivore eat? So it eats dead stuff. Now typically our dead stuff is going to be like dead animals. So your detritivore is going to act on this level, or this level. And your decomposers are getting energy from Where? Where? You're getting energy from everywhere, right? And what do decomposers do, basically?
They
Break down like the body into basically little nutrients, right? Little calciums, little carbons, little everything, right? Who uses those nutrients? Mostly, primary producers use those nutrients. When you fertilize the ground with compost or whatever, that's really helping out your primary producers. Now, could that help out you? I guess it could if you were interested in making vitamins from like minerals in the ground, but typically you're not. So your nutrients are really absorbed by those primary producers. Now, if you look at this planet and you see that this planet is entirely all of these reactions like repeated over and over for each ecosystem, I would say from this chemical perspective, because that's what you're looking at your chemical cycles here. Your chemical cycles would appear to be closed and exclusive to Earth, right? Assuming that you avoid a discussion of any kind of rock coming in from outer space, asteroid, or whatever. But is the energy, is that open or closed? Is the Earth open or closed with respect to energy? Open, because where are we getting our energy from? So, realistically, I should draw a picture of the sun up here, and then show its energy going to there. And with the pencil, I'm showing energy direction. With the purple and the black, I was showing the food direction. See all these different arrows I can draw. Somehow energy, though, is, in the end, energy is going down this direction. It's just more confusing. You don't know.
This diagram has just got arrows all over it now.
Yeah, but think about it. It's simple, dude.
I mean, not the, just the arrow thing.
I mean, but here's the other thing to focus on too is that, like, if this system, if I'm meaning for this to show the planet Earth, you see how energy is coming in from the sun, and because of an inefficiency in basically glycolysis, Krebs, and citric acid cycle, or Krebs or citric acid cycle, and then oxidative phosphorylation, because of that level of inefficiency, basically what we have here is we have a system in which you have like low energy, I guess, output at each level. You're having lower energy output. In other words, it would take tons of primary producers to feed just a couple of primary consumers, many primary consumers to feed just a couple of secondary consumers. So there's like a low energy throughput, you could say. And also, as the energy comes in from the sun, it's exiting this planet as heat. So with respect to energy, our system, this planet, is open, but with respect to cycles, we're closed. Cool? So I want to make sure we understand, again, that there's new energy coming into this planet, but there's no new carbon atoms coming into this planet. Are we 100% set on that? Okay. See some people zoning out, so that seems like it's good stuff. I would advise you to not zone out, otherwise you probably will get stuck reading this chapter tonight. Primary production. What is a primary production? Who's doing that? Typically plants. So therefore we're talking about photosynthesis. Okay. What primary production measures is it's basically the amount of sunlight, or the amount of light, converted